All right, students. So we were discussing changing in physical states last time. So let's get started with it. So large changes in temperature and pressure can cause changes in physical states that we discussed last time. Okay. So this can cause a substance to change its physical state. The changes in three states can be easily shown. You're already familiar with it. You have studied in previous classes that a solid can be converted into a liquid, or a liquid can be converted into a gas simply by heating them, or we can do the vice versa. I mean, we can convert the gas into a liquid or the liquid into a solid by cooling them. Okay. So which are known by different names as different processes such as melting, freezing, boiling. There are many names to it. Okay. So what we are going to do is that we are going to discuss all of these one by one, definition by definition. But before we do that, we have a diagram here on the book. This diagram. Now, I hope this diagram is very clear in terms of arrows. Okay. Take a look at the bottom where the solid is written. Now, the solid can be simply converted into a liquid by the process of melting, in which we usually heat a solid, and the solid melts and is converted into a liquid. Now, we can convert the liquid into a gas by the process of evaporation or vaporization. We may also call it boiling. You're familiar with the word boiling instead of the word vaporization. However, you might also be familiar with the word evaporation. We'll do them definition by definition a little later. Then a gas can be converted back into a liquid by the process of condensation or liquefaction, and a liquid can simply be converted back into a solid by freezing or solidification. Some words might be new words for you, but the rest they are pretty familiar because we have studied them in previous classes, usually year 5, year 6, and year 7. Okay? So by definition, melting is when a pure substance melts is suddenly at a particular temperature and the solid form is converted into a liquid form. That happens by increasing the temperature as shown in the arrow over here. Freezing is actually the reverse. In case of freezing, the reverse takes place. I mean, a solid liquid is converted back into a solid sharply at the same temperature, but this time we are cooling it instead of heating it. So it's the opposite to melting. Now, evaporation and condensation take place over a range of temperatures. Boiling, however, takes place at a specific temperature, or liquefaction, however, takes place at a specific temperature. Okay? So, apart from these processes, there is one more process written over here in the form of such a large arrow, which is sublimation. So, sublimation is when few solids, not all solids, go through sublimation, change directly from solid state to gaseous state on heating, and they bypass actually the liquid state. And this term sublimation is used for direct change. Okay? And that can happen in either direction. A gas can directly be converted into a solid, or a solid can directly be converted into a gas. Okay? In this case, the liquid step is bypassed. All right? Let's take an example in order to understand it. For example, in case of solid, we take the example of ice. In case of liquid, we take the example of water. And in case of gas, just a second, in case of gas, we take the example of water vapors. Now, in these cases, you would understand that ice can be converted into water simply by heating it, or water can be converted into water vapors by heating it more and more, which we do through the process of boiling. However, water vapors can be collected and can be converted back into water by cooling them a little bit, or water can be converted into ice by cooling it much more than what required before. And hence the water can be frozen into ice. The process of converting water into ice or ice into water happens homes daily, almost daily, in our simple daily life chores. Okay. Are we familiar with these examples, class, or do you have a question? All right. If you do have a if you don't have a question, that means it's easy. So what we are going to do is that we are going to go definition by definition. Um, let's go back to the previous page. So the temperature at which a pure substance turns into a liquid is known as melting point and can simply be written as MP. Take, however, the entire phenomenon would be known as melting. The process would be known as melting. The temperature at which this occurs is known as melting point. So we are doing two definitions over here. This always happens at one particular temperature for each substance. So that temperature would be fixed for the substance. See? The process is reversed at precisely the same temperature if the liquid is cooled down. So yeah, the process can easily be repeated or reversed at the same point, but this time the cooling process would be there and the liquid can be converted back into a solid. It would be known as freezing point or simply be given as FP. All right. So the melting point and freezing point are going to be the same for most of the substances in the world. For example, for water, that takes place at 0 degrees centigrade. Now, this portion is important because this quotes an example of conversion of water. Now, the ice will be converted at water at 0 degrees centigrade, and the process would be known as melting, while this 0 degrees centigrade temperature would be known as melting point. However, if we're going the reverse, the water is being converted into ice, the process would be known as freezing, and the 0 degrees centigrade at the same temperature in which water would be converted back into ice would be known as freezing point. Are we clear with this example? Any questions? Okay, so talking about another example, gallium is a metal that has a melting point just above the room temperature. Because of this, it will melt in a person's hand, and the example is quoted here in the diagram. Take a look. This is a metal bar, and this is getting melted in a person's hand. Because its melting point is usually just above the room temperature. Here we use the word room temperature. Room temperature is usually taken as 25 degrees centigrade around the world. 25. However, human body temperature, as we have studied previously in different science books, is 37 degrees centigrade. So it melts a little above 25, and on human body temperature, the solid metal is converted into a liquid. This was the example. Now moving on to the other process, we also need to go with the process of sublimation. A few solids, not all solids, such as carbon dioxide, which is actually a name of a gas that we usually exhale. Jivita, Zainab, do you want to ask a question with that?
No, sir.
Okay, so just a second. Now, sublimation only happens for a few solids. Gas, carbon dioxide gas, which you're familiar with from biology books, that carbon dioxide is the gas that we exhale every time we breathe out, okay, is commonly known in its solid form as dry gas. Dry gas is the solid form of carbon dioxide. Why do we call it dry ice? Because it looks like ice, but it's not wet because it's not made of water. Okay? Carbon dioxide, when it's frozen into ice, looks like ice, but is not wet because it does not contain any water, hence is known by the name of dry ice. Do not melt when heated at normal pressures. Okay? Instead, they directly turn into gas, carbon dioxide. So dry ice would be converted into carbon dioxide. See, let's take an example for that. So what I'm going to do, class, is that I'm going to stop this sharing and we are directly going to take help from a video over here. Okay? Just give me a moment to do that. Okay? This is going to be in the dry ice experiments compilation for chemistry students. Let's take a look. This is dry ice.
Yes, sir.
Jivita,
Yes, sir. Dry ice से तो smoke निकलती है.
बिल्कुल बेटा, because it's carbon dioxide. हम इसे स्मोक इफेक्ट्स के लिए अपने हॉल में भी यूज करते हैं. आपने देखा होगा कि हम एनुअल डेज पे स्मोक इफेक्ट देते हैं अपने हॉल में. दैट इज टेकन फ्रॉम ड्राई आइस.
सर फिर इससे क्यों निकल रही?
अभी निकलती है बिकॉज यहाँ पे टेम्परेचर बहुत ठंडा है जहाँ पे वो काम कर रहा है. वेट, यू विल सी दैट. जस्ट अ मोमेंट. Look, as soon as he changes the temperature, this is the smoke effect we were talking about. Just simply combining the dry ice solid piece with hot water. Take a look at how magnesium ignites. This reaction comes in the later part of the book, in chapter number 8. But as we are going through dry ice, so you are in advance looking at an experiment from chapter number 8. So these were the simple properties of dry ice. You don't need to go through the entire properties of dry ice, just that we can convert it back into carbon dioxide by simple easy experiments, by simply increasing the temperature. All right. Coming back to the book. So sublimation is actually the conversion of dry ice directly into carbon dioxide or carbon dioxide into dry ice. However, in this book, we are going to take many other examples of substances that can sublime. Okay. In order to make sure that we note all of those examples, I'm going to write them over here. Just a second. Carbon dioxide is one of the examples. We are also going to take the example of iodine in this book. Then we're going to take the example of ammonium chloride. And lastly, naphthalene. Please make sure that you also write it on your book, because just one example for sublimation compound is not enough. So we are going to go with more examples. The second example would be iodine. Make sure you write it on your book. The third one would be ammonium chloride. And the fourth one would be naphthalene. These are the examples that we are going to use for sublimation through our entire book. A couple of pages after, we'll use the example of iodine. After about 10 pages, we'll use the example of ammonium chloride. And in chapter number 10, we'll use the example of naphthalene. So any questions regarding sublimation? All right. So for the second example, as I was just saying, the iodine is going to be our second example. This happens at a particular temperature for each solid for the process of sublimation, and we use the word that the solid sublimes. Iodine is another solid that sublimes. Okay, it's moving on. Just a second. For iodine, here's the example. Let's take a look. Iodine is actually a gray-black solid, and when we heat it a little bit, it produces a purple vapor, a purple gaseous form, which can condense back into the colder part of the tube or the cool part of the tube into solid iodine. Take a look. This is the gray-black solid, which is converted into a purple gas over here. And when it moves farther from the warmer part, which is actually the colder part of the test tube, it converts back into these gray-black solids, which are deposited over here again. Claire, can we all see it? Okay. Any
Yeah.
questions so far from sublimation? Okay, moving on.
Sir, how do we break dry ice?
How do we break what?
How do we break dry ice?
Break? We can simply,
Break.
we can simply break it with the help of a metal, like the person was doing it with a spoon. Although it produces a fizzing sound when we do that, but yeah, we can do that easily. You can also do it with a hammer, but then it would split into many parts instead of just two. Are we clear?
Yes.
Okay, good. Anything else before we move on? All right, class. So moving on. Getting back to the point where we were. So that is the example of iodine. Okay. As I said, it produces a purple vapor, but then condenses back again into a gray-black solid on the colder surface. Moving on to the next definitions. Now, in case of evaporation, boiling, or condensation, there are three more definitions that we need to go with. We're going to start with evaporation. If a liquid is left with its surface exposed to the air, it evaporates. We're familiar with that. Splashes of water evaporate at room temperature. After rain, the puddles, the water that gets accumulated in shallower parts are known as puddles. Those puddles dry up and the liquid change into gases in a slower process that we know by the name of evaporation. Evaporation takes place from the surface of the liquid, and the larger the surface area, the faster the liquid evaporates. Now, are we familiar with this last line? The larger the surface area, the faster the liquid evaporates. Can anyone give an example from your house that larger the surface area, the faster would be the liquid evaporating? Anyone
Sir,
quote an
I think,
example?
sir, can I take?
Yeah, yeah, sure.
Sir, I think if we want to dry our clothes, then the more the sunlight will be outside, uh, the faster it will evaporate. The water
Yeah,
will evaporate and the clothes will become.
good try, Reach. But actually, if we go out in the sun, the faster evaporation is not due to the larger surface area, it is due to the higher temperature. Because out there in the sun, the temperature is higher than what is inside your rooms. So that effect is not written over here, of course, but that is the temperature effect. How is the surface area going to affect the rate of evaporation?
Excuse me, sir.
Yes.
If we take a larger pan and put the same quantity of water in it, the pan with a smaller surface area will not evaporate that quickly with a larger surface area.
Right, very good example. If we take a larger pan and try to evaporate the same amount of water, then we do it in a smaller pan. Comparatively, the larger pan will evaporate the water faster than the smaller pan. That's very good. So if we take the same example as Reed's example, and if we take the clothes that are wet, remember, you might have seen it with your own eyes. Then when we wash clothes, what happens is that we need to dry them up, right? So in order to dry them up, we never mumble jumble the whole cloth into a ball-shaped form. What do? We try to spread them. And usually what do we have for that? We have wires in our house, the proper wires for the drying of clothes that are usually present in the topmost floor of the house, okay, where it can get a lot of sun, where there is a lot of air, and we can easily dry them up, and we spread them on the wires just to make sure that they are properly dried up. Even if we use an electricity based evaporator, what we do is that we can give them a whirl in that evaporator, and after that we try to spread the clothes onto a proper place, and it gets dried up quickly. So if you're going to mumble jumble the whole thing into a ball form, okay, it won't dry up quickly, but if you're going to spread them, it will dry up quickly. So this act of spreading them up, okay, actually gets them a larger surface area and faster the evaporation. In order to fasten up the whole process, we try to increase the temperature. We do that by putting them in sun, because that way they are dried up quickly, right? So apart from temperature and surface area, which other factors are going to affect the rate of evaporation, or are going to make the rate of evaporation faster? Can you count a couple of factors more? I'm asking you to do that because we have usually done it in our previous classes in year 5, in year 6, in year 7. I don't know whether you remember it or not, but the factors of evaporation are a part of previous books. So can you count a couple of factors more other than temperature and surface area? Anyone?
Sir, if the liquid would be more hotter, it will evaporate faster.
Actually, that would be temperature, because hotter liquids have higher temperature. So I'm asking for factors other than temperature and surface area. Try to think. Can you come up with something? Let's start in making guesses. Scientific educational guesses. There is no problem with a wrong guess. You can always make a guess in a class. So, any guesses, please? How about asking new students? How about asking Halima and Umama? Halima and Umama, any suggestions? What other factors might affect the rate of evaporation or can get us a faster rate of evaporation other than temperature and surface area?
Sir, I think I know.
Just a second, let me ask Halima and Umama and we'll come back to you, Zoya.
Sir, pressure.
Pressure, very good. Okay, Alia, you are correct, but we have discussed this before. So yes, the air pressure, the faster the flow of air, the quicker the clothes will dry. Very good try, Halima and Umama. Yes. What else?
Sir, density.
Yeah, density. Usually the less dense liquids tend to evaporate faster than the high density liquids. Yes, nature of liquid or density of liquid matters too. Very good. And here I like to quote, please make sure that you write these factors on your book. One of them is density. The other one would be air pressure or flow speed of air or speed of air simply, temperature, and lastly, what we'll have over here is humidity. So let me write the factors over here. Factors affecting rate of evaporation, and that would be uh, temperature, air speed, and density of liquid or nature of liquid, and humidity. Humidity is the last thing. I hope you understand by the word of humidity that in this case, uh, specifically in these 2 months from 15th of July to 15th of September, we have a lot of rainfall throughout Pakistan. So it's difficult to dry up our clothes in this season. But if we talk about May and June, that is the hottest season, hottest months through the entire year. So that's very easy to dry up our clothes in those times. So if their humidity means the moisture in the air, if there is too much moisture, it would be difficult to dry up things, then there is less moisture. So temperature, airspeed, density of liquid or nature of liquid, and humidity are the factors that affect the rate of evaporation. Are we all clear about that?
Excuse me, sir.
G.
Sir, will fluidity affect the affect evaporation?
Fluidity cannot directly affect evaporation as fluidity depends upon density. So if we consider fluidity a factor, yes, we can, but that would be approximately equal to density. So fluidity, density, or nature of liquid means the same thing. Well, good try, good work. Okay, make sure you write these lines in the book. And then we are done for the day. Some students entered after I was done with the attendance. I think that was Adan Khan and then Bilal Ahmed, Alia Zahra, Ibrahim.
सर बिलाल कह रहा था उसका अपडेट हो रहा था इसलिए वो आ नहीं सक रहा था.
It's okay, it's okay. I'm just saying these names so that if I miss anyone, please let me know. And I'll make sure that I mark them.
Excuse me, sir. Sir, I am present. Muhammad Ibrahim.
Chipita, I just went through your name. Okay? Okay, I think that would be all. Take care, class. Allah Hafiz.
Allah Hafiz, sir.